Welcome everyone. My name is Victor. I work here at CloudWalk as a prompt engineer, and I will be talking about today. I will be talking about an approach that's called the needle-in-the-haystack approach, and it's basically about testing LLMs to understand within the prompts, right? So the text that we input to them, their capacity to retrieve information from within that prompt, right? So in what they call in-context learning, which is when we give the LLM some information and we ask them to extract an answer based on that information. This was quite an interesting paper in the sense that recently, especially, quite a lot of the more foundational models have been open to larger and larger and larger prompts, to the point where we have GPT-4 Turbo with a 128,000 token context input limit, which is crazy if you think that, for example, a year or so ago, we had models that had at most 4,000 tokens in terms of input. And that seems to be a trend when we're talking about different models. So we have GPT-4 with that. We have Claude coming in with quite a large amount of tokens. We have Llama being trained with larger token input sizes. And this seems to be a shift in the paradigm, right? It seems to mean that pretty much we are able to give LLMs more and more and more information for each task. But that doesn't necessarily mean that the LLM will be able to retrieve and use that information in the correct way. And that's pretty much what this paper is exploring, right? So just as a general introduction, here we see the models that were analyzed, and just so we have a general idea of how many tokens each model takes in terms of the input, and what we're talking about when we're talking about how the methodology of the paper worked, right? So we see that quite a lot of models are 4,000 tokens still. That seems to be around a quite a usual amount, but then we see GPT-4 Turbo here popping in with a massive amount of tokens, right? And at least in this comparison. And basically, the methodology of this paper was that they took within the text, there was a task, right? So there were 3 specific situations that I'm going to show them to you. The basically question and answer pairs, where they took a huge amount of input text, right? And they asked the model to answer a question based on a factoid that was inserted in the middle of the text, right? So in this example here, I basically took an excerpt from the Divine Comedy, and I basically inputted in the middle of the text, just in the middle of the whatever was going on, the paper club happens once a week, right? So if you would replicate this, basically what we would do is we would ask the model, when does the paper club happen? And we would expect the model to sift through the text, trying to find this needle in the haystack, which is the filler text, which is the Divine Comedy in this case. So just so we can have a look, these are the 3 questions that were asked. The first is the Pistachio AI. So the factoid is, Pistachio AI received a patent before its Series A, and then at the end there was the question, right? So what did Pistachio AI received before its Series A? Same thing with a question about San Francisco. So the best thing to do in San Francisco is eat a sandwich and sit in Dolores Park on a sunny day. And then the question, what is the best thing to do in San Francisco? And then Thornfield Hollow. The best thing to do in Thornfield Hollow is to eat a sandwich and sit in Harmony Glen Nature Preserve on a sunny day. And then what is the best thing to do at Thornfield Hollow? I think these 3 tests were basically structured and selected in order to present 3 different kinds of information, right? So in terms of Pistachio AI, is a fictional company. So there would be absolutely no information in the training data at all about Pistachio AI. So there's a certain verisimilitude about the question, but still, it would be completely novel information. The San Francisco question would involve quite a lot of information already in the training data. So we have to assume that the training data for a lot of these models includes travel blogs, includes includes guides, includes just general information about San Francisco, and that's going to be relevant a bit later. And Thornfield Hollow, it's also fictional. It's a fictional situation. It's a fictional case, but the verisimilitude in this and how similar it is to other questions about nature preserves or national parks or whatever is also quite large. And in general, so just going back, in general, what we see is that the closer we get to like the end of the model, right, to the complete size of the input prompt, the harder it is for the model to look for the information within the prompt and retrieve the correct information, right? So just so we can have like a general overview here, we're looking at GPT-4 Turbo, which is the largest input size. So in terms of the San Francisco text, we see degraded responses after about 20,000 tokens, like overall across the board, except for at the beginning and the ending of the input length, which is quite interesting. So capable of looking at facts right at the beginning of the system prompt, but right at the end. In terms of the Thornfield Hollow test, there was a degraded performance as well, but much less widespread than in the case of San Francisco. And in terms of Pistachio AI, was quite good at doing that retrieval, right? So, okay, let me just pull up the paper here and let's have a look. So that's the thing we talked about, the haystack construction, the prompt structure, and the evaluation, something I forgot to mention. The evaluation itself was done by a GPT-4 Turbo instance, right? Since it's, at least as of now, April 26, 2024, the most recent model and the most advanced model in the GPT family. It was used to evaluate, and it's basically giving a score from 1 to 5. It's like, oh, the answer is completely unrelated. That would be a 1, and the answer is completely accurate and aligns perfectly with the reference. So we see a degraded performance, but one thing that's noticeable is that the answer is never completely unrelated for the Thornfield Hollow and the San Francisco tests. That might be related, especially to the data that's already in the underlying description, right? So it's not going to hallucinate something crazy like the best thing to do in San Francisco is to have a drink on the moon, right? That's not something that's going to happen. There is some certain verisimilitude and logic within the responses. Okay, so looking at the discussion, I think something that pops up is that one thing that was already kind of empirically known, but it's becoming more descriptive, more relevant in this paper, is that like information at the beginning and the ending of the prompt has always been considered to be more relevant, right? So it's going to be retrieved better. So at the beginning, and if you want something to be remembered at the beginning or at the end of the prompt, that's where you need to put it. Scores for models with a lower amount of parameters and versus a higher amount of parameters, even if it's the same models. For example, Llama 13B versus Llama 17B reveals a better performance in 70B, right? So that is something that was already kind of expected. I mean, these larger models have a better performance in general. And there is something that was quite interesting, suggesting that how you do the fine-tuning and how you train the model to retrieve information from within the prompt will improve the performance in these kinds of tasks, right? So a lot of this is things that I already mentioned. The question between the comparison between the Pistachio AI prompt, the San Francisco prompt of Thornfield Hollow, right? What happens when the prompt conflicts with the training data, right? So as I mentioned before, let me go back to the presentation. When we're talking about the Pistachio AI test, this is an information that was completely novel to the model, right? So the model could never rely on the underlying training data to complete this response. So you see quite a good performance on it and a good and the model not really getting mixed up. Doesn't matter where it was in the prompt, or how long, like how large the prompt actually was, right? The same thing happened with Born Tool Hollow. So kind of an invented place, but you see kind of like a degraded performance when it started getting lost in the middle of a lot of text, right? Because there is some similarities to, for example, let's say like national parks, so Grand Canyon National Park or something else, especially in the US, right? It's very US centric, the training data, and they do have quite a lot of things in terms of nature preserves. And in terms of San Francisco, we see the performance degrading quite quickly, right? Because, like I said, probably something to do in the training data. So it's very hard coded into the model weights already, this information, right? So as long as the information is not necessarily hard coded or similar to something in the training data, you see a better performance. Okay, so yeah, this is just pretty much going through the results. We're talking about Llama 13B having a worse performance than the Llama 70B, which is also doesn't make sense because it's a larger model. But we do see that, for example, for a slightly smaller haystack, right, we don't see that much of a difference in performance, which is interesting. The study also suggests some differences in architecture in the training strategy. So, for example, Mistral 1 versus Mistral 2, different architectures in the same test perform significantly differently, right? So terrible performance for Mistral v0.1, 0.2 already a better performance. And for Mixtral, which pretty much does a mixture of experts, basically model quite a better performance situation. And then just pretty much detailing something here about the fine-tuning and the restructuring of the training data, right, and just nudging it in the right direction. When we compare Wizard LM to Llama 70B, considering that Wizard LM is a fine-tuned version of the Llama 2 model, we see that Wizard LM has a better performance. And when we see the difference between the Turbo GPT 3.5 Turbo instances, the more recent ones, which basically the largest difference is how the model was fine-tuned, tend to have a better performance as well. So yeah, pretty much the thing is, why exactly is this meaningful, right? So it's quite a short paper, quite a quick discussion, but what we're talking about here is as these models start getting longer context windows, and as we start dealing with training, like with input data that is notably different from what's in the training models, like in the training data, how much can we trust the model to kind of sift through the information and find what is relevant, right? And there have been a few approaches, right? So at the beginning of the whole LLM discussion, like right back there, like early 2023, we were talking about using RAG for the models which had at most, for example, 8,000 tokens in terms of context. What is RAG? It's retrieval augmented generation, right? You use a vector-based database or just another way of retrieving data from an internal database to get information before you gave that to the model, just so you can kind of get around the token limitations for the model, right? So what this paper suggests is that there's not only a benefit in terms of getting around token limitations, but also there's a benefit in keeping prompts shorter and snappier and more direct, basically, so that the model can understand the needle, like the factoid that you're looking for, in a better way. And that seems to, even as the models get better and improve, that seems to be a thing, right? That seems to still be true. Because even if you do have a massive context window, if you have something similar, so in terms of, we're talking about CloudWalk, we're talking about a financial institution, right? And we're going to be adding information to our models about the financial institution itself and our specific practices. Since our specific practices have some certain internal verisimilitude with banking practices worldwide, or things that were used in the training data, or news that happened in the training data, it's quite likely that the model will get confused if we just throw a bunch of information into it, right? So there's still quite a large benefit into RAG and into adding the correct factoids in a shorter, snappier prompt. That seems to be working. That seems to work better. So going back to the presentation, just so we can, so yeah, I was talking about RAG, and basically, because right now it seems to be that the retrieval augmented generation, which would avoid all that filler text, is still the most relevant paradigm, right? And this was quite a short paper, and I wanted to open up to you guys. I know that quite a lot of you have been working with LLMs, and I wanted to know your experience, because I'm guessing that you kind of tested out this a lot, and I would happy to add my experience, even though I pretty much already did. So yeah, what do you guys think? Any questions?
Well, nice presentation, Victor. I think like the paper itself, it's like you said, a short paper, but very simple experiment, right? You have 3 situations basically, and then you try. And I think you explained very well, because I was a bit confused at first. Because basically that's it, right? How, like, some stuff that I think, like the pistachio case, I think even like the name pistachio, right? Of course, you can have like some attention on there. It's a usual set of tokens, I suppose. That could be like, I think is easier to find, right? And then you have the others that the data itself may have like something. So I think, for example, like CloudWalk, right? Even CloudWalk, right? Because you have the Chinese company, the Brazilian company, and then if I don't know, one of these companies was much larger here than the other, an LLM could struggle to explain, right? Say like, oh, the Chinese company, I don't know which one, but like if you one is much, if there is another company that's named Google, I don't know. It would struggle sometimes, right, to identify, like, if you have a chat bot for this smaller company, and probably it would be a hard time to try to remove this kind of previous knowledge, right? And I think also the way the text is, right, like you said, like pistachio AI, and then the other case about the fictional place, right?
Thornfield Hollow.
Yes, so it's kind of, the other is kind of similar to what may appear on the data set, right? So it's really, that's why I think it's harder as well.
Because that's something, even if pistachio and pistachio AI is something that is, I think it's less about being unusual tokens, and it's more about pistachio not usually being associated with AI or technology.
Yes, as well, yes.
Yeah, so if we're talking about, for example, if it was a factoid about pistachios and tree nut allergies, probably would be confused in larger, in larger haystacks, right?
Yeah. Yes. And I think I remember, I don't know exactly, but I think I remember like some paper that the LLM itself identified that it was apparently they are benchmarking and something like that, or like crazy. That like you added, I think it was very more similar to the problem that you presented at first. Like you have like a text, a book, and then in the middle of the book you put some information. And I think I remember, I don't remember the paper, but I remember like reading something like that. And then say, oh, I think you're trying to test me, but this information is this one. So it was able to find it, to kind of identify, oh, you want to test me. So, because the test is too perfect, and then there's this random thing in the middle. So maybe it was too obvious. But yeah. Anyone else has any other comments or questions?
I was going to make a comment because at the end, like Victor said, there are some structures that work best, like short phrases, very objective. I don't know if we can leverage this type of information in order to better pre-process the information that we provide the models before doing RAG and other stuff, because when we do the experiments like feeding the model with the whole knowledge base from CloudWalk, I don't think that information is very compatible with this type of structure. So maybe we could use the LLM to improve first the text for later querying it, because this is very interesting, like thinking about this combination of key and query for the attention of the transform neurons. So when we have more explicit and obvious structures, maybe the mechanism will work better. Something that I was thinking about. Not sure how to do it, but maybe we could exploit it.
Yeah, I think there are some ways to. So I do know that we have some projects that in which we pre-process the information quite a bit so that it's more palatable for LLMs, right? And that we do specific kinds of RAG to get the correct information. So we do generate a better query based on the customers. So for example, for Claudio, generate a better query based on this customer query, based on their history, right? So in order to retrieve, and the knowledge base is quite optimized, because I mean, given that we have 128,000 tokens, we could definitely add the entire knowledge base at once. But we see that that's another limitation of the study as well. I wanted to see how it would perform and test how it would perform when you want a factoid that's inserted within text, similar text, right? So instead of being like so it was text about San Francisco National Park and Pistachio AI inside a bunch of essays. I don't remember exactly someone's essays, Graham something.
And they mentioned this OX, like this Mac OS stuff.
Paul Graham essays. And then who is Paul Graham, right? So this kind of thing. Yeah, computer scientists. So if there was a question about, I don't know, an information about startups, like it's actually quite interesting, like that the Pistachio AI as a startup was well retrieved, right? Because if we're talking about startups, this is actually quite interesting that they were able to retrieve the correct information. So that's actually an interesting bonus, and I don't think they mentioned it on the essay itself. But yeah, I would love to see that test. So we're talking about financial information, and we're talking about like 15 different cases of fraud, and we want a specific factoid. How do we retrieve that specific factoid, right? Instead of it getting messed up with different situations of fraud. But it's actually quite interesting if we're talking about texts about AI and essays about AI, and it was able to retrieve something about Series A funding for Pistachio perfectly, then that sounds like an actually quite a good result for the models, right? Quite good performance.
And do you think there could be some bias on the paper because they use GPT-4 for the evaluation of itself?
I think so. Yeah, I do think so. Maybe I think that's one of the limitations. They could have used some other like 2 or 3 models and made kind of like a council of evaluators, right?
Okay, go ahead, sorry. No, just saying that like they could also try to get like some people try to, even if not in the entire data set, but some human evaluation, like something like that, right?
Yeah.
Right.
What they mentioned is that there were like thousands of responses, right?
Yeah. No, yeah, but yeah, it's not feasible, but like a sample could try to say, okay, we mostly agree GPT-4, etc.
Yeah, it was somewhat minimized in the sense where, let's see, I think there's a evaluation.
Yeah.
Let's see.
And
Yeah,
also,
please act as an impartial judge, yada,
yeah,
yada, yada. But still, it is quite.
Yeah. And also, it's the score, right? Because I think maybe it's easier like to score like yes or no, but this is kind of like is a ordinal variable, right? It's 1, 2, 3, 4. So it's a thing that I don't know. I never read anything about how if it's GPT-4 is more direct, or if it's like it is like I think we had a talk about this recently, right? About being human, right? If you want to score something sometimes, and then if you want to score maybe an answer, you're more direct. But if you want to score like some person or anything like that, like we are more likely to give like, oh, this person is very good instead of this person is very bad. So it skews a bit. Like we don't score ones, we put more 5s, 4s, and 3s, and they're like, oh, it's not that great, so we put 2. So it's a bit skewed, right? So it's a thing.
Yeah, if you look at the heat maps, there are not that many, yeah, except for Mistral here, but there are not as many reds as you would expect, right? Red being 1.
Yeah.
It's more like 3s, 2s, so that's interesting.
Yeah, at least you would expect transition zones, right? I don't know.
Yeah.
An answer, yeah, I don't know. If the behavior is approximately continuous, then you wouldn't expect like a green to a red.
Yeah, I mean, I think it's more. I agree with you guys, but I think it's. I've been thinking about it more as like the true false, like bad versus good eval. Anyway.
Yeah.
Maybe if they opened up the model to reason about its response, right?
Yeah, yeah.
Because we do have like that improvement with GPT. Because if we look at the judgment prompt here, it's like strictly follow the format. This rating X, right?
Yeah.
Yeah.
But there was one interesting thing on the last plot that you showed, that there's kind of an oscillation. I think when at the bottom, I think the bottom is when the information is at the edge of the haystack, right?
Yeah, at the bottom is when at the edge of the haystack, yes. So fact placement depth, so 100% is I think the most recent, and 0% is the most, like it's the oldest.
Okay. Yeah, what I found interesting is that like the model guesses right, then it guesses wrong because we increased its size. It's still placing at at the end, and then it comes back and it starts getting it right again.
Yeah, I think you're talking about this, right? Like green at the point, green at the edges, and then kind of orange and.
No, when we have like a green column, then a red column, then a green column. Like when we increased the size of the haystack, the model started guessing wrong. Then we increase it again, and then it started getting it right.
Yeah, there's some oscillation here. Like you're talking about in this situation, right?
Yeah, exactly. It's interesting. I don't know how to interpret that, but
yeah,
I think it's interesting.
I don't know either. I think there's like I don't know if this study was done with enough accuracy for us to be able to analyze in detail every specific situation. But I agree with you that it's quite interesting because like here, you do see the oscillations, quite significant oscillation.
Does the study mention like each one of these points there, this little squares there's how many tests are there? Like each point of this is like 1, or do they run like for a depth like 1.2 and 535 of haystack size, they run like 3 times, and then they take maybe the average score at least 3 times, you know, instead of just running once, because then you know.
Yeah, that would smooth it out, right?
Do they mention like it's just 1, right?
Yeah, I think it's just 1 for each situation. I don't think they ran it various times.
Yeah, but since But I don't know, because the color scale is continuous instead of discrete. I don't know.
Yeah, good point.
Like you have some orange, then maybe.
Yeah, but I don't think it's continuous. I think it's discrete. I don't.
Okay, it's just for plotting.
Yeah, I think it's for plotting
Convenience.
purposes, but like
Yeah.
there is nothing in between here, right? It's just
Yeah.
Makes sense.
Yeah, maybe that's why there's some of these weird plots, right?
yeah, it's like a specific. So they ran once for each one of these little squares, I think.
Yeah. Yeah, and thinking about matrices, right? Have one for each, so it's kind of a lot of comparison. So I imagine it was a bit costly.
Yeah. Because yeah, that's something that they mentioned, that it's cheaper to evaluate with just one model as well.
Yeah.
Pretty cool.
But yeah.
Okay. Any other comments, guys? Well, I think not. So thanks, Victor, for the presentation. I think it's makes you rethink, right? And also about these regs, right? Because they also have this dilemma, right? Regs, it's kind of funny because it's kind of new, right? I think like late 2022, like ChatGPT and everything. And like, oh, regs appeared, and then like you have people that now are claiming that since you have models that have huge context windows, like regs is dead, anything. And I don't know, maybe regs is not the final solution, but I think definitely it helps, and also it's more efficient, right? If these models are bigger and bigger, the processing time is high, it's larger and larger as well, right?
Yeah.
And another thing that I forgot to mention is that I think also works for ambiguous stuff, right? Because then you have some stuff that I think we know a lot about, right? About money, where is the money? That's very ambiguous. And if you have a huge context window, maybe the model gets more confused as to why. And if you have like some methods to just showing some specific relation as to why to answer some question, I think that's improve. I don't know. I never read anything, but I imagine that if you have like something that's general and you want to solve a problem, and you want the model to answer like in a specific way, I don't know, it should be more specific to help to align with the paper. Well, the paper not with the answer that we want.
Yeah, I think empirically I would tend to agree with you. But yeah, I haven't seen anything written about that.
Yeah. There's the work here to be done. Okay. But okay, guys, I think that's it. Again, thanks, Victor, for the presentation. It's really interesting to know more about it.